Hello everyone, my name is Abhishek Datta and this is the problem solving session on soil mechanics geotechnical engineering 1. So the session of the first week that was held on 29th July with the technical issues, the solution video in the same session could not be recorded. So this is a separate solution video for the same. I have already uploaded a video where some of the questions have been dictated to the students, and now in this video I'm going to solve those questions one by one. Uh, the the main topic of this week is origin of soil and its classification. So the video is already being recorded, and I'll start with the discussion now. So regarding this topic, this topic has 21 questions approximately, and it combines of multiple choice with multiple select questions, true false statements, numericals, everything. The first question was, what is the type of soil formed after deposition in lake water? What is the type of soil formed after deposition in lake water? So the answer to this question is the answer is lacustrine soil. The answer to this question is lacustrine soil. And the other options being shown here, like alluvial soil, colluvial soil, and marine soil, I'm going to explain them as well. Like we all know, alluvial soil formed from the transportation by the river water. Alluvial soil are formed transportation by the river water, and colluvial soil are formed by the deposition activities of gravity, of the gravitational forces. And about marine soil is formed by transportation from the sea water. So these are the three other options. I'll just write it down. So as I've mentioned, the alluvial soil is transported by the action of river. Alluvial soil by the action of gravity, and marine soil by the action of seawater. So this is the deposition and transportation of soil during the formation cycle of soil. This is an important part which states that soil formed at one place might be transported at another place and then deposited over there. So this transportation agents decides what is the kind of soil that has been deposited at a particular place. Okay. So type of soil formed after deposition in lake water is, the answer is lacustrine soil. I will now go to the next question. The next question is, a lacustrine deposit with alternate thin layers of silt and clay is called. Lacustrine deposit with alternate thin layers of silt and clay is called. The answer to this question is barb clay. Barb clay is formed from the deposition in the lake water. It is a lacustrine deposit. It has alternate thin layers of silt and clay. Silt and clay are fine grained soils. Okay. Now coming to the other options, loam, morum, and bentonite. What are these? So loam is a mixture of sand, silt, and clay. Loam is a mixture of sand, silt, and clay. I'll just write it down. Loam is a mixture of sand plus Muram. What is muram? Muram is gravel which is mixed with red clay. Muram is gravel mixed with red clay. Red clay. What is bentonite? Bentonite is decomposed volcanic ash. Bentonite is decomposed volcanic ash. Bentonite is decomposed volcanic ash. So all the options, I guess, they'll be clear now. Loam is a mixture of sand, silt, and clay. Muram, gravel plus red clay. Bentonite, decomposed volcanic ash. And the answer to this question, that is lacustrine deposit with alternate thin layers of silt and clay, is called barbed clay. It's called barbed clay. I hope it's clear. Go to the next question. Which of the following are formed by transportation by gravitational forces? As I've mentioned in the first question, that transportational agents play an important role in depositing the soil from one place to another. And these transportational agents decide the type of soil formed at a particular place. So here, the question is, among these soils, which are formed by transportation by gravitational forces, by gravity? The answer to this question is talus, because talus is the type of colluvial soil. Colluvial soil formed by gravity. This is the type of colluvial soil. Now, what are the other options? The other options are, first of all, loess. Loess is aeolian soil. It's transported by the action of wind. Till. Till is glacial deposit, transported by the action of glaciers. Glaciers. And laterite is formed and deposited in the same place. So laterite is a type of soil which I will discuss in the next question. There is a question regarding that particular type of soil. But laterite is formed at its place. Formed its wherever weathering takes place, the soil is not transported but formed in the same place. Such kind of soil is laterite. And the name of the type of soil I'll discuss in the next question. So I guess it is clear. Loess is transported by wind, tail is transported by glacier, laterite is formed in place and transported by gravitational forces. The answer to the question is talus, because it is a colluvial soil. It is a type of colluvial soil. I hope it is clear. I'm going to go to the next question. Yes. Which of the following type of soil remain at their place of formation? Which of the following type of soil remain at their place of formation? So the answer to this question is residual soil. Is residual soil. Why? Because residual soil, laterite itself is a residual soil. Laterite itself is a residual soil, because wherever weathering action takes place on the parent rock material, in the parent material, there the soil is not transported but formed in the same place. They remain in their place of formation and they are not transported from one place to another. So these kind of soils are called residual soil. And so what are the other options? Aeolian soil, I have mentioned. Aeolian soil are the soil which are transported by wind. Transported by wind. Marine soil are the soil transported by sea. And colluvial soil are the type of soil transported by the action of gravity. For example, talus. For example, Aeolian soil transported by wind, marine soil transported by sea, alluvial soil transported by gravity. And the answer to this question, the type of soil remains at their place of formation, is residual soil. I hope it is clear. I will go to the next question. Which of the following processes may lead to disintegration of rocks? Which of the following processes may lead to disintegration of rocks? Now, disintegration of rocks is the first process uh, that initiates the formation of soil. So it is the rock, the parent material, on which weathering happens, erosion happens, and then finer particles, that is soil, are formed. So when this weathering, erosion, or disintegration in general sense is happening in a rock mass, which processes may come into action, whether they're chemical or physical or biological or all of this. So the answer to this question is option 4, all of this. It is because disintegration or weathering can be chemical. Why chemical? Because of the action of some solutions. Some geological activities might go on which may release some chemicals, some solutions, which may cause disintegration, alter the structure and the composition of rock. The disintegration can be physical also. For example, an external force acting upon a rock mass that breaks it physically without any change in the chemical composition. So that is the physical change in the rock mass. The disintegration can be biological also, by the action of microorganisms or any other creatures that might lead to weathering and subsequent erosion of rock mass, which in general sense we can say disintegration of the rock mass. So all these three processes, chemical, physical or biological, can take place together or one by one or two at a time, can take place to erode, weather the rock mass and bring about the formation of finer particles of soil. So all of these processes, chemical, physical and biological, may lead to the disintegration of rocks. I hope it is clear. The solution is clear. Go to the next one. So this is a true and false statement. Soil transported and or formed by different processes are constantly subjected to further change by physical, chemical or biological actions. Soil transported or formed by different processes are constantly subjected to further change by physical, chemical or biological actions. So once the soil has been transported from one place to another or formed at a particular place, even then it can be subjected to further change because of the never ending, you know, actions of nature. It can be physical. After a soil is formed, it can experience external forces which might lead to compression of the soil. It might undergo any chemical processes due to any geological activities or anything of that sort, any external man-made interventions also. It can also undergo biological actions because of the action of microorganisms or any other animals. So once the soil is formed, even then the process that had led to the formation of soil might come into play. So soil transported and or formed by different processes are constantly subjected to further change by physical, chemical or biological actions. It is a true statement. The process is never ending. The process is actually never ending. I hope it was clear explanation. I'll go to the next question. Which of the following processes leads to change in the structure of the rock and not its composition? Which of the following processes may lead to change in the structure of the rock and not its composition? So, change in structure means only change in the physical structure of the rock. and composition means chemical composition. So it is clear that anything that will happen which might alter the physical structure of the rock and not chemical composition. So chemical change or chemical action will not be there. So in this case, the answer to this question is abrasion. Abrasion is scratching action on the rock surface, which might change the structure of the rock. Now, what are the other options? Carbonation, addition of carbon dioxide in the form of solution. Hydrolysis is breaking down of any compound in the action of water. And reduction reaction, as we all know, it is uh, the addition of hydrogen ions or the subtraction of oxygen ions. So these carbonation, hydrolysis and reduction, these are chemical process, and this might lead to change in the chemical composition of the rock mass. Now, only change in structure can be caused by abrasion, which is just a physical process, scratching on the rock mass surfaces that might lead to change in its appearance. So the answer to this question, that the process which will lead to change in the rock structure without any change in the composition, the answer is abrasion. I'll go to the next question. Cohesionless soils are formed due to. Cohesionless soils are formed due to. First of all, we have to understand what we mean by cohesionless soils. So cohesionless soils are the soils where the cohesive force is zero. So the cohesive force is zero. It means cohesion or the interparticle attractive forces in the soil mass is zero or very negligible. If it is not zero, it is very negligible. It can be ignored. So these type of soil are generally coarse grained soils like sand and gravels. These are cohesionless soils. Finer particles like silt and sand, they have silt and clay, they have cohesive force. So the fine grained soils, clay and silt, they are generally having the cohesive force, and the coarse grained soils, sand, gravels, they are generally lacking in cohesion. So these are the cohesionless soils. Now, how are these cohesionless soils formed? Cohesionless soils are formed only because of the majorly because of the change in the structure of the rock mass. Change in the structure of the rock mass. So when rock mass starts disintegrating, because only because of the change in the structure, whatever soil is formed primarily, they are all the cohesionless soil. They are all cohesionless soils. So change in structure, it refers to the physical disintegration of rocks. It refers to the physical disintegration of rocks. Here, the option wind action can also be true, but wind action can cause other changes apart from physical disintegration also. So the specific can generalize both. If we consider both the cases, then physical disintegration of rock is the correct answer. Now the other options like oxidation of rocks, it brings about a change in the chemical composition of the rock mass. Oxidation, addition of oxygen, that will not be forming cohesionless soils. The second option, leaching action of water on rocks. So if there is a leaching action of water, water might contain some solutions which might bring about chemical change in the rock mass, change in the chemical composition of the rock mass, and that again will not lead to the formation of cohesionless soils. So physical disintegration of rocks or breaking of rocks, breaking which leads to change in the physical structure, is a major process that brings about the formation of cohesionless soils. I hope it was clear. Go to the next question. It's again a true false statement. Weathering process related to the activities of microorganisms is termed as geochemical weathering. Weathering process with respect to the action of microorganisms. So what is geochemical weathering? Geochemical weathering is hap- mainly happening. It mainly happens because of the action of the chemical solutions which are produced because of any geological activities. Now, when microorganisms is concerned, the term we use for the action of microorganisms is generally called biological weathering. It is generally called biological weathering. Also, in some cases, we can find the term biochemical weathering. That means the action of microorganisms is aided by the action of chemical substances either produced by the microorganisms or any other geological activities. So, in general sense, this statement that weathering process with the action of microorganisms termed as geochemical weathering, this statement is a false statement because the generalized answer to this question will be biological weathering. Weathering process related to the activities of microorganisms is termed as biological weathering. So this statement is a false statement. I hope the explanation was clear. I'll go to the next question. Uncemented deposits of mineral and or organic particles covering large portion of the earth's crust is called. Uncemented deposits of mineral and or organic particles covering large portion of the earth's crust is called. Now the options, though they are similar, but the statement of the question is a very generalized definition of one term, that is soil. So when the material is uncemented, that is, it is loose, it composed of mineral and or organic particles and covering large portion of the earth's crust. It is definitely soil. Loam is a type of soil, and rock is generally found under the soil surface as a bedrock. Rock is not covering large portion of the earth's crust and is definitely not uncemented, though it has mineral or organic particles in it. What are aggregates? Aggregates are generally geomaterials which are used for building purposes or any other construction purpose or civil engineering, any other civil engineering purposes like highways, buildings, bridges, dams, which are formed from disintegration or decomposition of parent rock mass only. So the answer of this uncemented deposits of mineral and or organic particles covering large portion of the earth's crust is called soil. This is a basic engineering definition, layman definition of soil. Okay, I hope it was clear. I will move on to the next question. Alluvial deposits at foot of hills or mountains is known as. Alluvial deposits at the foot of hills or mountains is known as. So by the term alluvial deposit, we mean those soil which are transported by the river action. The sediments transported by river. Now when they are deposited at the foot of hills or mountains, then that deposition is called Piedmont deposits. That is called Piedmont deposits. Now, what are the other options over here? Loess, as I've said previously, loess is the soil which is transported by wind. It is an aeolian soil transported by wind. It is not necessarily that it has to be deposited at the foothills or mountains, but it is not alluvial deposit, so it can't be considered. Deltaic deposits, deposition formed at the river mouths. formation formed at the river mouths. So they are transported by the river and they are definitely alluvial deposit. It is formed at the river mouths. So the place of formation, the place of formation is different. It is not deposited at the foot of hills or mountains. It is deposited at the river mouths. The third option, that is estuarine deposit. It is a mixed deposit of marine and alluvial origin. It is also deposited at river mouth, but it is a mixed deposit of marine plus alluvial. It is not exactly alluvial deposit. It is marine deposit plus alluvial deposit. This is also deposited near the river mouths. Marine plus alluvial deposits are called estuarine deposits. So deltaic deposits, alluvial deposits deposited at the river mouths. Loess is deposited by transported by wind, which is not alluvial deposit. Estuarine deposits, it's a combination of marine and alluvial deposit at the river mouths. Piedmont deposits are the alluvial deposits. It is formed at the foot of hills or mountains. The answer is Piedmont deposits. Okay, I'll go to the next question. The biggest size of clay particle is. The biggest size of a clay particle is. The biggest size of a clay particle is 2 microns as per the Indian Standard Classification System. 2 micron, that means 0.002 millimeter. As per the system, the biggest size of clay particle is 2 microns. The biggest size of a silt particle is 75 microns. That is 0.0075 mm. Is 75 microns. It is the biggest size of a silt particle. Beyond this, the biggest size of a sand particle, I believe it is 4.75 millimeter. Above which they are the gravels. So the biggest size of a clay particle is 2 micron. Anything less than equal to 2 micron or 0.002 millimeter can be considered as a clay particle. And above that, up till 75 micron, it is a silt particle. Clay and silt are what we call fine grained soils. They are the fine grained soils. Okay, I hope it was clear. We'll go to the next question. Okay. So, silty clay indicates. Silty clay indicates. Now we have entered into the classification system of soil. Previously, the origin of soil was covered. Now it is the classification system of the soil. So, silty clay, what does it indicate? When we say silty clay, this word, the first word silty, acts as a kind of adjective for the main soil, that is clay. So, clay is the main soil, and silty clay, that is, it is describing the type of the main soil. So, silty clay, silty, this word silty is describing the type of clay. So if clay is the main composition, obviously the percentage of clay will be more than that of silt. Will be more than that of silt. So silt percentage is less than that of clay. This is the correct option. Silt percentage is less than that of clay. This is as per the nomenclature. And when we say something like sandy clay or clay sand, the first term, it acts as an adjective to describe the main soil, which is in the second term. So if we say silty sand, that means it is sand composed of less percentage of silt. So silt percentage is less than that of sand at that time. Similarly here, when we say silty clay, that means silt percentage is less than that of clay. Clay is the main soil, and what is its composition apart from the main soil? It has silt. So it is silty clay. I hope the explanation was clear. I will now go to the next question. Okay. BIS soil classification is based on. BIS soil classification is based on, BIS means the Bureau of the Indian Standards. Bureau of the Indian Standards. So this classification is based on. So this is based on the grain size distribution, of course, because we need to know the grain size to classify them as fine grain soil and coarse grain soil, and again fine grain soil between clay and silt, and coarse grain soil between sand and gravels. Okay. Now also, apart from this, the degree of compressibility in a particular soil is also a deciding factor. So this degree of compressibility or degree of deformation can be known by the plasticity properties. For example, liquid limit, plastic limit, shrinkage limit, plasticity index, liquidity index, consistency index, these are all the plasticity properties. So plasticity properties, that is the degree of deformation or the sensitivity of the soil along with the grain size distribution, both these factors decide from the basis of the soil classification as per the Bureau of Indian Standards. So the answer to this question is BIS soil classification is based on grain size distribution and also plasticity properties. So the answer is both of the above. BIS soil classification is based on both grain size distribution of soil and its plasticity properties. Okay, I hope it was clear. Next question. Boundary classification is to be resorted to. Boundary classification is to be resorted for coarse grain soils when the percentage fines is. Now, boundary classification is to be resorted, that means this classification system is first of all dependent on the percentage of fines. So in coarse grain soil, if it is sand or gravel, we have to check whether fine grain soil like silt or clay is present or not. And then again, we have to check for the percentage of the fine grain soils. Check for the percentage of the fine grain soils. Then as per the percentage, we can tell whether the soil, that is the coarse grain soil, need to be resorted for boundary classification or not. So in this case, we'll see the options one by one, and then we can find out the solutions like that. The first thing is greater than 12%. What does it mean? It means that the percentage fine, that is in a particular coarse grain soil, sand or gravel, the percentage of silt or clay is greater than 12%. If it is greater than 12%, then we write the nomenclature like this. Suppose it is sandy soil. We write like this. SM is, M means silt, silty sand, or like this. SC, C means clay, clay sand. That means when the percentage fines is more than 12%, we take the fine grain soil composition, fine grain soil percentage into consideration while we go for the soil nomenclature. And we tell it like this: silty sand or clay sand, or similarly GM means silty gravel or clayey gravel, GC. We can write like that. Okay. When the percentage fines is less than 5%, there is a percentage of silt or clay is less than 5% in a certain soil mass composing of sand or gravel, then we do not take that percentage of fines into consideration for the nomenclature. Instead, we write like this. Suppose it is a sandy soil, we write like this: SW if it is well grained, or SP if it is poorly grained soil. So in that case, we go by the gradation of soil. We go by the gradation of soil, well graded or poorly graded. If it is sandy soil, well graded, in SW; sandy soil, poorly graded or gap graded, it is SP. Okay. Now between 5 and 12%, this is the answer of the question. This is when we resort to boundary classification. When the percentage of fine, that is the percentage of clay or silt, is between 5 to 12%, 5, 6, 7, 8, 9, 10, 11, 12, any of this percentage we can find out in a given soil mass of coarse grain soils, then we give the nomenclature like this. Suppose it is a sandy soil, then we'll write, if it is a well graded sandy soil consisting of suppose silt, then we write well graded sandy soil, we give a hyphen, and then we'll write this, and we call it like well graded silty sand. SWSM means well graded silty sand. First of all, we mention the gradation, then we mention the percentage fines. Well graded silty sand. So boundary classification is to be resorted for coarse grain soil when the percentage fines is between 5% and 12%. This is the answer. I hope the explanation was clear. I'll go to the next question. Among the given soil, the specific surface is the highest for. Among the given soil, the specific surface is the highest for. Now specific surface, the formula is surface area per unit mass. Surface area per unit mass. Now we all know that among these sand, silt, gravel and clay, gravel has the maximum particle size, then comes sand, then comes silt, and then comes clay. Clay has the minimum particle size. So if the mass is constant, suppose I take 1 gram of sand, 1 gram of silt, 1 gram of gravel and 1 gram of clay. So 1 gram of each if we take, then gravel will have the least number of soil particles, gravel particles, and clay will have the maximum number of soil particles. So larger the number of particles, more is the surface area per particle and more is the surface area of the overall soil mass. I repeat, larger the number of particles in a given mass of soil, more is the surface area per particle and more is the surface area of the entire soil mass. So if mass is constant for all this soil, then surface area will be highest for the soil which has the largest number of particles. In other words, which has the lowest particle size. So lowest particle size is clay. Lowest particle size is clay. So among these, the specific surface is the highest for clay. Is the highest for clay. And if we go by the symbols, then I write it over here. Clay has the maximum specific surface. Then comes silt, obviously, which has a bit larger size in clay but less than sand and gravel. Then it will be sand, and then the least specific surface will be that of gravel. Gravel will have the least specific surface because it has the minimum number of particles for the same mass of soil. Okay, so specific surface is the highest for clay among these soils. Okay, hope it was clear. I'll go to the next question. Yes, soils which plot above the A line in the plasticity chart. Plasticity chart is made by the Indian Standard Classification, where as per the grain size distribution and the compressibility, the chart is used for classifying soil. Now this is the plasticity chart, and I have another question over here. So in these questions, I believe we'll be using this plasticity chart. This is the plasticity chart as per the Indian Standard Soil Classification System, and here in this plasticity chart we have the liquid limit on the x-axis and plasticity index, that is the difference between liquid limit and plastic limit, that we have on the y-axis. Now the first question was the soils which plot above the A line in the plasticity chart. So we first need to describe the plasticity chart. So this is the A line. This is the A line, as we can see over here. This line, the equation of this line is IP, that is the plasticity index, IP equal to 0.73 into WL minus 20. WL is the liquid limit. WL is the liquid limit. IP is the plasticity index. So now this A line, if we see, we have this A line and we have two vertical lines over here. One is cutting at liquid limit 35, another one at liquid limit 50. Now below this A line, we can see all the soil are having nomenclature as M. M means silt, and above the A line, the soil has a nomenclature of C mostly. So we can say that above the A line, it is clayey soil, and below the A line, it is silt. Above the A line is clayey soil, and below the A line, it is silt. Now, the next thing to look out for is below the A line, we can see O is written. O means organic. Below the A line, it is organic. And if O is not written, then by definition, it is inorganic. OI means intermediate plasticity. OH means high plasticity. H means high plasticity. I means intermediate plasticity, and L means low plasticity. Okay. So apart from the plasticity, we can say that organic soil are found below the A line, and above the A line it is the inorganic soil. Below the A line it is the silt, and above the A line it is clay. So above the A line we can now say that it is clay and it is inorganic. Okay, so do we have the option over here? Yes, we have the option. Soil which plot above the A line plasticity chart, they are inorganic clay. So above the plasticity chart, O is not written, it is inorganic, and C means clay. So above the A line, it is inorganic clay. Okay. Now we come to the next question. Again, we'll be using the plasticity chart. A soil has liquid limit of 20% and plastic limit of 14%. As per IS classification, the soil is. So liquid limit of 20% and plastic limit of 40%. I'll just calculate the plasticity index. Is IP equal to 20 minus 14, liquid limit minus plastic limit. It is liquid limit minus plastic limit. So this is how much? It is 6. IP is 6. Plasticity index is 6. Now, if we go to this plasticity chart, we can see there is a small zone below, just above the A line. Now, we define this zone as starting from plasticity index 4, ending at plasticity index 7. Now, if we look at the question very carefully, the soil has a liquid limit of 20. So liquid limit we need to mark in the chart first. Liquid limit of 20 means this one, this line, this vertical line. Now, apart from the liquid limit of 20, the plasticity index which we have found out is 6. That is the y-axis. Plasticity index is 6. 6 means lying between 4 and 7. That means this zone. So this point is somewhere around here where M is written. So this is falling in the shaded region. And what is this? This is above the A line, so it is inorganic. This is written C and M. This is again a boundary classification, C and M both. C and M both, that means what? If it is C and M both, that means it is both clay and silt. And both has L written, that is low plasticity. So we can say that the soil we have, it is first of all inorganic because it is plotting above the A line. It is composed of both silt and clay, and it is having low plasticity. So we can see now we have an option number 3, inorganic clays and cells of low plasticity. Why inorganic? Plotting above the A line, clay and silt, C and M is written, and low plasticity because L is written. So this is the right answer. Inorganic clays and cells of low plasticity because it is falling in the shaded region in the plasticity chart. Okay. So soil having liquid limit 20 and plastic limit 14. As per the Indian Soil classification, it will be inorganic clays and cells of low plasticity. Okay. I'll go to the next question now. Yes. If the soil retained on 75 micron sieve is more than 50%, the soil is fine grained. Now 75 micron, this is the maximum size of silt. Maximum size of silt. Beyond this, you can find sand and gravel, and below this, you can find clay. Maximum size of clay is 2 microns, 0.002 mm. Now, so 75 micron, this is the boundary for the fine grained soil. Fine grained soil is the boundary. So if the soil retained on this sieve, on this size of sieve, is more than 50%, that means more than 50% of the soil mass are having a size of more than 75 microns. That means more than 50% of the soil mass are having a size which is more than silt. That is, it falls under the coarse grained soil. The soil will be definitely coarse grained and not fine grained. I repeat once again, this question means that more than half of the soil mass is retained in a 75 micron sieve. It means that more than half of the soil falls beyond the maximum size of the fine grained soil. So more than half of the soil falls in the range of the coarse grained soil. So is the soil fine grained? No, the soil is definitely coarse grained. It is not fine grained, it is coarse grained. So this statement that is soil retained on 75 micron sieve is more than 50%, the soil is fine grained, it is a false statement. It is a false statement. The answer would be it is a coarse grained soil. If the question was like this, the soil passing through 75 micron sieve is more than 50%. That means more than 50%, more than half of the soil is passing through this sieve. That means more than half of the soil is having a size, particle size, which is falling within the range of fine grained soil, which is less than the maximum size of silt. So that soil will be fine grained soil. But this one, since it is retained, that means it is having a size of more than 25 micron, so it is coarse grained soil. So this 75 micron is the boundary which decides whether the soil is fine grained or coarse grained. More than this, it will be coarse grained. Less than this, it will be fine grained. Okay. I hope the solution explanation was clear. I'll go to the next question. A soil has a liquid limit of 30. The corresponding plasticity index given by the A line is the corresponding plasticity index. I repeat the question. A soil has a liquid limit of 30%. So in this case, the liquid limit of the soil is given. Now we have to find out the plasticity index given by the A line. Now we can see in this plasticity chart that we have an A line, and the equation of the A line is plasticity index equal to 0.73 into WL, there is a liquid limit minus 20. Liquid limit minus 20. So I'll just write this equation over here. Equation of the A line is A line this equation is plasticity index IP equals to 0.73 into WL minus 20. Now what is WL? WL is the magnitude of liquid limit in percentage. So WL is basically 30 in this formula. So if we solve this, 30 minus 20 is 10, 0.73 into 10 is 7.3. The answer we get is 7.3. So what does this signify? If a soil has a liquid limit of 30%, then the A line will give the plasticity index of the soil as 7.3. As 7.3. Okay. So this is the correct answer. The third option, 7.3. As per the A line, the equation is plasticity index equal to 0.73 times liquid limit minus 20, and on solving the equation we get the value of plasticity index IP as 7.3. Okay. Now the last question, group index of soil ranges such that now group index is another classification system that has been mentioned by the HRB, Highway Research Board. And in group index, we also take into consideration the particle size and the plasticity properties, that is liquid limit and plasticity index. So I'll just write the general formula of group index. Group index or GI, the formula is 0.2A plus 0.005 AC plus 0.01 BD. What are A, B, C and D? What are A, B, C and D? A refers to that percentage of soil passing which is between 35 to 75 percentage, and by percentage passing we refer to passing 75 microns. Okay, 75 microns. So 75 microns is an important thing to consider while we consider the group range. That is the size of silt which defines the fine grained or coarse grained soils. So in this case, A means that percentage of soils passing the 75 micron sieve which is more than 35% and less than 75%. So if we see carefully 35% and 25%, the range of percentage here considered is 40, that is 0 to 40. So A will have a value that lies between 0 to 40. 0 to 40. Similarly, B refers to that percentage passing through 75 microns which is more than 15% and less than 55%. I repeat, B refers to that percentage of passing through 75 micron sieve which is more than 15% and less than 55%. That percentage only we'll consider over here. So the minimum is 15%, maximum is 55%. Then the range again for B is 0 to 40. 0 to 40. Okay. Now what is C? C is that percentage of liquid limit falling between 40 and 60. If it is between 40 and 60, the liquid limit, that only we'll consider in C. And so 40 and 60 means the range is again over here 0 to 20. So if it is 0, that means the liquid limit is 40, And if it is 20, that means the liquid limit is 60. The difference of the liquid limit between 40 and 60 will be considered and represented by C. So the range of C, again, it is 0 to 20. And what is D? D is similar to C, but it is the plasticity index. It's not liquid limit, it is the plasticity index. So this is as per 75 micron. This part is also related to the 75 micron passing. Okay, this C is the liquid limit and D is the plasticity index. C is the liquid limit, D is the plasticity index. That fraction of plasticity index that falls between 10 and 30. So if it is 10, plasticity index will be 0, 10 minus 10, 0. If it is 30, plasticity index will be 30 minus 10, 20. So again, D has a range of 0 to 20. Now, if we put the minimum, that is the 0, in all these variables, the group index will be 0. And if we put the maximum, that is 40, 40, 20 and 20 in A, B, C and D respectively, the group index value will be 20. So the answer of this question is group index of soil ranges such that group index falls between 0 and 20 degree, including the value, that is, it is more than equal to 0 and less than equal to 20. Mind it, the second option will not be the answer, because in the second option the equal to sign is absent. That means this second option is not considering the 0 and 20, it is considering all values more than 0 and all values less than 20. But we can see over here, if we put the value 0 in these variables A, B, C and D, then the group index value will come as 0. And if we put the maximum value, that is A equal to 40, B equal to 40, C equal to 20 and D equal to 20, then the group index value will come as 20. So the group index will lie between 0 and 20, including both the ranges of 0 and 20. So it is more than equal to 0 and less than equal to 20 always. Okay. So this was the last question. I hope the session will be useful to you all, and next session will be on 29th. Next session will be on next Monday, that is on the 5th of July, 5th of August, I suppose. So next, the topic of the second week will be discussed in the coming session in the coming Monday. I guess the session will be on, yes, 5th August. So next topic will be discussed in next Monday. So this is the solutions for all the questions that have been discussed in the first sessions on 29th of July, and that will be uploaded today. Thank you.